right, here's a video on section 2.9. So you're going to want to look at page 217 and go ahead and pause this and try to fill out this chart, and then we'll go over it. So try not to cheat, just pause, try to figure it out, and then unpause and listen. Okay, all right, so this is the deal. You're looking at the object, which is like 17, and what's being done to it is operation. So this is square root of 17. So here, when you look at these two numbers, what's happening, they're really added. It's really 4 and 2/5, so the operation would be addition. Here, 8 and 9, even though it's a fraction bars mean division. Here, we're doing the absolute value, but what are we doing at ARN? A negative 10. Here, we're squaring, but the object is a negative 8. Now, I disagree with your book on this one. Here, I would say the object is 8, which they would agree with me as well. But I would say there's two operations going on. You're squaring first, and then you're making opposite. So that's why this one's a positive 64, because the object's a negative 8, and you're squaring. Here, the object is 8, and you square it, but then make it opposite. So it's a negative 64. So I would add the word opposite to that. All right, here they're focusing on multiplication, so the 2 and then all of the x plus 1 y are being multiplied. So the objects would be 2 and then x plus y. And then over here, the a and b are getting added, so that would be addition. Where here, if we look at all the a plus b and the 2, then we have division. Here, if we look at these separately, this is being added with that, so addition. Where here, if we're talking about division, it would be A with the 2 and B with the 2 division. All right, so let's look at the bottom of the page here. And just read this sentence. Oops, I went too far. Maybe, if I can get back to that. Let's see, might have to go back. All right, so read the sentence at the bottom of this page here. And in math, parentheses are kind of like commas in English. They actually mean something. So I like cooking my family and my dog versus I like cooking my family and my dog. So again, if I don't put a parenthesis in there, or in this case a comma, it makes it sound like I would like to cook my family and my dog and maybe eat them for supper, which obviously doesn't make sense. And then the second one, really it's clear that I like cooking by itself, I like my family by themselves, and I like my dog by herself. So just kind of know that parentheses mean different things with the order of operations. All right, so the next page, you can kind of look at that a little bit. There's an example at the bottom here. So when you're dividing, you can, oh, went too far here. Or did it scooch up on me? All right, when dividing, I can divide these two and those two. So I can distribute the division. So I get x and 1/4. So there's x plus 1/4. It's kind of like, in a sense, instead of dividing by 4, you're viewing this as 1/4, and then you're just distributing the 1/4. All right, so we're going to look at the next page. So try to divide our number 2. So just pause it, see what you get. I'll give you a clue. C is kind of tricky. So pause, try them on your own, try not to cheat, and then we'll come back and do these together. All right, let's look at these. So I need to scooch up a little bit. All right, so when dividing, I can distribute my division here like this. In a sense, it's almost like I'm taking 1/7 of 7x plus 7. So that's what we're really doing and distributing that. But here you can see you get x plus 1. And again, you have to divide all the pieces. The next one, distribute, which again, it's the same as kind of distributing this to that. But I get x over 7 minus 1 when I do that. Some teachers call this like the heart method, you know, because you can kind of see how it kind of makes a heart, but that's not a real mathematical deal. Here you have to be careful because this is saying take opposite of the answer to this. That negative's out front. So I need to get an answer to this and then distribute, or I can distribute and then get the answer. I'm going to do that. So I'm going to add the opposite. So I'm going to change this to adding and then negative, positive. All right, then I'm going to go ahead and do my little division thing. So I get a negative x over 7 plus 1. So that one can be a little tricky. And again, basically what you're doing is if you have, say, a 2-digit or a 3-digit, like say 48 divided by 4, you don't really need to do long division. You can just see, okay, 4 goes into the 10 1, 4 goes into the 1s twice, and get 12. And again, it kind of makes it heart shape. Now, the other way is totally legal. So if you have 4 divided by 48, you can reduce. I mean, you could divide, you know, and get 1 over 12. But if you have, say, like a, I don't know, like a 3 divided by 129 or something like that, you'd have to do long division or something like that. So, just know when you're reducing like this with algebra stuff, you need the top. All right, let's look at the next two. All right, so we want to find a counter example for these two right here. And try to avoid zeros and ones because they're kind of special. You know, 0 times anything is 0, 1 times 1 is 1. 2 is kind of special too because 2 times 2 is 4, but 2 squared is 4. So you might want to avoid those. But pick some numbers for A and B and then see if these are equivalent or not. So again, pause, make up numbers for A and B, do this math over here, do this math, and then same, do this math and do this math, and we'll see what happens. So pause and try those. All right, so I am going to just make up any number, and again, you could have made up different ones, that's fine. So if I do the math over here, it's saying add A and B first, and then, so 2 over A plus B is what, 8, which is the same as a fourth. Now over here, if I sub A in, I get 2/3, and then B would be 2/5. If I'm going to add those, remember it's kind of a pain in the bottom. You gotta get a common denominator. So I get 10/15 plus 6/15, which is what? 16/15. So as you can see, this does not equal that. So I basically proved that these guys are not equal. And that's what I was talking about earlier. You can't do this way, kind of an upside down heart. You can't do that. You can only divide like A plus B is a single digit, so I can divide this way and get A over 2 plus B over 2, but you can't do it the reverse order, and that's what I was trying to state earlier. But I think this example probably shows it better. And I'm just going to keep my same values for A and B here and see what happens. So if I sub it over here, if I add, I get 8, and 8 squared is 64. But if I do it separately, I get what? 3 times 3 is 9, and 5 times 5 is what? 25. I get 34. So again, you can see that I have a counterexample. Those are not equal. And the reason that is remember when you square, you get 4 parts in your square. So you have A plus B, so remember you get A squared, AB, and B squared. So you're going to get a trinomial, not a binomial. And remember, if you're like, well, sometimes you get a binomial, that's true, but it's never plus, and it's only if it's opposites over here. So if you get like x plus 5 and x minus 5, that is the only time you'll get a binomial, but notice you'll get x squared outside inside, and then you'll get negative 25 because these guys will cancel. So, and notice it's minus, it is definitely not plus. But that's a special case when it's A plus B, A minus B, and then again that gives you A squared minus B squared because your outside inside cancel. But again, that's a one-time deal. All right, so the last part here is we are going to, let me erase a little bit, I'm going to go up, is that last part. And if you read the envelope thing on the bottom of page 219, if you do the opposite, things undo each other. So like, for example, if you take a left, right, left to get to school, then when you go home, you're going to have to take a right, left, right. You can't do what you did, and you have to do everything in the reverse order. So with the envelope, if you fold a paper, put it in an envelope, seal it, the other person is going to have to do everything in the opposite order and do the opposite. So instead of sealing it, they're going to unseal it. Instead of putting the paper in it, they're going to take it out. And instead of folding it, they're going to unfold it. All right, so look at number 5. They want you to take that formula, this one. Oops, that's a 3. Now let's just erase it. So you have what? 3n squared minus 2. And go ahead and sub 5 in and do order of operations. And then do the same thing to the second one. So go ahead and sub in n equals 5 to both of these. and see what kind of answers you get, pause it, and then come back. All right, so I'm going to sub 5 in, so let's see here what we're going to do. So the first thing we would do is square and get 25. The next thing we would do is multiply by what? 3 and get 75. And the last thing we would do is what? Subtract 2 and get 73. So if we know the answer, which right now we do, and we want to go backwards, notice we're going to do everything in the reverse order, and we're going to do the opposite thing. So the last thing we did was subtract 2, so that means that's the first thing we're going to do. And notice we get the 75 that we found right there. Okay, the second thing we did is multiply by 3, so we're going to divide by 3 to undo that, because again, we're trying to undo order of operations. And so now we get that, which was our 25. And then the first thing we did was square, so the last thing we're going to do is square root. Now, let me erase a little bit more of what we had below. So if I square root, now technically when I square root, I actually get 2 answers. I get n is 5 or a negative 5. Because 5 times 5 is 25, and a negative 5 times a negative is 25. And this degree 2 tells me I should maybe get 2 answers. So, although we know that n is a positive 5 because we know what we subbed in. So, if they told us that the answer had to be a positive number, then we would definitely know that it was a positive 5. All right, let's look at the next one. All right, if I sub 5 in there, I'm going to do this. So, the first thing I would do is what? Subtract 1. So that would give me this 4. The next thing I would do is multiply by what? 2. So that gives me 8. And then the last thing I would do would be divide by 3, which would give me some decimal. All right. So I'm not going to divide it. I'm going to leave it like this. But I could divide by 3 and get, what is that, 2.6 repeating or something like that. Or even a mixed number. All right. So now we're going to solve it. 2n minus 1 over 3. And that was equal to what? 8/3 is what we got. All right, so we're going to do everything in the reverse order and do the opposite of what we did. All right, so the last thing we would have done is dividing. So we are going to multiply by 3 to undo the division. And notice when I undo it, I get my 8. All right, now I have this. And I'm going to undo my multiplication by 2 by dividing by 2. And so notice that gives me my n minus 1 equal to 4, which is right there. And then the last thing I'm going to do is I'm going to go ahead, oops, I was going to erase there, not do that. The last thing I'm going to do is the opposite of what I had up here, which was what, subtracting 1. So I'm going to add 1 to both sides, and n equals 5. And that is the answer that I started with. So when you solve equations, you're basically doing order of operations backwards. So you're going to get rid of add and subtract first, then multiply and divide next, then exponents, and then parentheses, and all that good stuff. Now, we could use some properties here and there to do things a little differently, but that is the gist of it. So for homework, do section 2.9, page 221, 4 through 7, and I will get this video uploaded as soon as possible.